Well, hi and welcome to my shop this morning. I'm going to do a little more work on this radio. Got a few things in mind here to work on. So one of them is to check the cathode resistor on the output tube, which I haven't done yet. And another one is test all the vacuum tubes in here. I haven't done that yet, even though they all seem to be working pretty well. And I think the one I want to start with is what's going on with this coil, which I noted earlier appears to have a broken wire on it, yet the radio appears to be working kind of okay, so that's kind of a mystery. So I think that's where I want to start. What's going on with this coil? And we'll just work our way through each of these things. Now, what is going on with this coil? Good question. What did I see on it that made me think the wire was broken? It's right in here. So we'll get a nice close-up of this. First, let's take a look at this on the schematic. See if there isn't information about what each of these terminals is doing, because the wire that's come off appears to be from this terminal. Sometimes there's terminal diagrams and other helpful stuff in the manual or in the schematic. So let's go have a look at it. Okay, so we're looking for what I believe is the antenna coil. Now, how do I know that's the actual antenna coil? So, it may not be. Well, obviously the antenna itself is a coil. Well, this is the only other one in here. Really? No, there's this. Well, that's an IF coil. That's an IF transformer. So it must be this. It must be the oscillator. So I kind of thought it was an antenna thing going on up here, but it's not. Okay, so how can this possibly operate if it's open? So I suspect that that wire is not really broken on this thing. And I have tuned this radio. It has tuned things in. There is an oscillator signal reaching the tube, and it's pretty close to appropriate in frequency. Hard to believe how you could have any problem in this coil and have A, the thing oscillate at all, or B, oscillate at the right frequency. So we got to take a close look at this, because maybe there's really nothing wrong with it at all. As for the terminals, well, let's see, there's going to be 4 of them. Wow, this is going to be hard to track down, I think. Got the start and finish for the coil. Not terribly helpful to me in a repair situation. There's no other information on here at all. Is there? Oh, yes there is. What's this going to show here? So this is on top. Of course, I'm underneath. Not going to show it. That's the end of the road there. Alignment procedure. Okay. Yeah, let's take a close look at this coil and see if I'm just mistaken in the whole deal. Well, yeah, is that broken off? What's going on there? Let me get a tool here. I'm going to tug on the wire. I think it's still connected. I don't want to be the one who disconnects it. Now, I was flipping this right out as if it was broken earlier, wasn't I? I don't think it's broken. Wow. So last time I looked at this early on, when I yanked on that wire, I thought for sure I could see the free end flying around. But I guess it was just an optical illusion or failure to see what's really there. Considering the fact that the radio works, this is the oscillator coil. If this coil was messed up, this radio just would not work. It just wouldn't work. So I think it's all okay. How it got yanked out of the wax there, Who knows? Who knows the answer to that question? Certainly not a lightning thing. Nothing to do with the antenna. You can't damage this coil by hooking something up to the antenna, not without exploding the entire radio. So that issue is a non-issue. It's a non-issue. I'm kind of a little bit suspicious that that was the case all the way along because of the fact that the radio kept working. So that's number one done. Number two is going to be the cathode resistor, which I already know is this guy right here on the output tube. Now that guy is supposed to be 240. Let me just make a quick check here. 240 ohms. So we're going to find out if he's 240 ohms or not. And I'm going to do that just by hooking up an ohm meter. I'll do it with these short clip leads here. It's a low resistance. Supposed to be 240 and it's coming in at 300. Now, is the reading? Well, first of all, if this resistor was 240, then this meter would read 240 or something less. So this resistor is 300 or something more, because it could be a parallel path. I haven't really thought much about it. What's in parallel with this is, what's in parallel with this is a little tiny filter capacitor that I put in the back here. So 300 versus 240. I think I got to change that and make sure it's at 240. Now let's do something interesting. We'll look in my tube book and just see what it says about this tube. This is was a 35L6, wasn't it? 35L6. 35L6. So could I just put a 50L6 in there and cut out that dropping resistor from the series? Why would I even want to do that? 35L6 beam power tube, mounted in any position. That's good. The radio's on its side here. This type may be supplied with pin 1 omitted. So what we want to look for is under cathode bias operation. It'll give the cathode resistor. Cathode bias resistor 180. So it's actually smaller than what's in the radio. Now, I mean, this is based on, this number 180 is based on operating the tube the way they did to make this book. Like with 200 volts on the plate. Well, this doesn't have 200 volts on the plate. It's got, I don't know what's got, 130 or something like that, was it? 110, only 110. So the actual value is decided by the designers of the radio, and I best stick with it. At least looking in the book gives you some notion. And they're all in a few hundred ohms range. That's typically what goes on. So I'm going to replace this with a brand spanking new 240 ohm resistor. Oh my gosh, I just discovered that you can just turn this radio upside down and sit it on itself. It's really quite secure and easy to work on. Oh my gosh, I've been doing all this work with it on its side. It could have been like this. There's the resistor I'm after. Here's the replacement. This is a 250 ohm resistor. That's a 240, well, 240, 300, whatever it is. Can't find an actual 240 resistor, so this will be good though. 250, go a little bigger, make a little higher bias, a little less current flowing through the tube. Better to go higher than lower, I think. And I don't think this will make much difference. Anyway, okay, we'll put that in there. Okay, so I got the resistor in. Now, it's time to do the tubes here. Let's see what happens with that. Might as well start with the rectifier tube. Z5. Okay. Okay. So I've got it set for the 35Z5. Interestingly enough, I didn't realize it, but there's also a 35Z6 and a 35Z4 and a 35Z3. Didn't know that. 35Z5. Okay, pop them in. Pick one of these. Maybe this one. There we go. And right then we'll flip it on. Whack. Good show. I'll double check everything. 35 volts, 35Z5, 35. That's a rectifier we're testing, so we don't set this, we don't set that. 07003, 07003, 0610, 0610. Good. Short test. No shorts indicated. I got this correct. I got that correct. E. Yeah, good. Diodes and rectifiers. And where does it have to come? This is a rectifier. It's supposed to make it all the way up to this area here where it says rectifier is okay. Ooh, rectifier is okay. And there's no other 35Z5. No, there's nothing else to it. That's it. No surprise there. I mean, and the radio itself is a pretty strong test of the tubes. Okay, let me pull out the output tube and we'll set up for this. 35 volts and the 35L6 should be just right around here. 35. There it is, 35L6. Signal level 8. The bias is 14H. 07345. 07345. 35L6. 07345. 0610. 0610, same as before. Sensitivity 43. D. X. 4. Okay, so 990. So about 1,000 on here. So this should come up to there. 35 volts, right? Right. There we go. Now, once again, because the radio's working, I mean, the fat chance that this tube is really, really sick. But let us find out anyway. No shorts showing up between tube elements. GM test. Still warming up. Oh, this is why this radio is so slow. It's this tube. And it's way, way up over 1,000. Way up. It's at 2,000. 35L6. 990. 990 and it's reading 2,000. She's a beauty. She's a beauty. Right home about this one. Okay, next on the hit parade here would be the, let's do the detector tube. I could have sworn as I put that tube back in the radio, the speaker made a sound. And the radio's not plugged in or anything. Yeah, sometimes when I'm soldering, the sounds come out the speaker. 12SQ7. Maybe it's the pain of the heat or something. So before we get any further, put this onto there. Make sure that's not wrong. 12 SQ7. 12 SQ7. 13 volts, correct. Signal level 1. Bias 18L. Okay. 25100. 25100. 3760. 3760. Sensitivity 37. F. Should read 760. That's the reject point. Should be above 760 or throw it away. And so first thing we're testing is the triode side of this tube. Okay, the voltage is 13. Wow, So I'm wearing my headphones. I don't normally wear headphones when I'm working in here. I don't normally listen to the sound because it's a little problematic, but because I'm over here at the tube tester, I've got the headphones on to hear the sound properly. So I'm hearing a bunch of things that are no doubt all over my videos. I hear them on my videos that you regularly hear in my shop, like the pop when I operate this. I don't hear those normally. So occasionally you're getting clues and I'm not even getting them. I'm essentially clueless. Okay. 760. 760 is well, that's 500, that's 1,000, so we're right in the middle here. Oh, well above. Good tube. Remember, I thought this radio didn't have much mileage on it. We don't know if these are the original tubes or not, but it could well be. Now we'll check the diodes here. We'll change it to 2013P. 20. Whoops. Let's not do that. 2013P. Some of these tube testers, you have to do what I just did. You got to pull the tube out when you're changing these settings. My other tube tester, you can do whatever you want until you push the test button. Nothing's on that tube except the heater. Of course, you'd be setting the heater setting. This is the heater setting here, I believe, down here on this tube tester. Okay, did I make a mistake now? 2013P. 2013P. 0760. 0760. 48. A. So there's two diodes in here, and we can select them with this P button or plate button. We can select plate 1 or plate 2, which we will do 2 tests on the 2. And now, since I was talking so much, I'm just going to double check again. Single 1, 25100. 2. What did I do here? 12 SQ7. 12 SQ7. 18L. Oh, yeah. Okay, 201. Yeah, 2013. I started reading the wrong line here. That's what happened. 0760. 48. Yeah. Okay. Even though I was talking, I got it right. So just like in computers, chip manufacturers manufacture chipsets, and you get all these chips that all work together quite nicely. You buy the set, put them in your computer when you're a manufacturer. Same thing with tubes. Tubes were kind of issued, maybe not so much as a set, but there are certain groupings of tubes you always find together, like this one, 6 SQ7, 6 SK7. Very, very common tubes in these radios. Okay, we must be ready to go here. Must be ready. Checking for leaks. None showing up. And this is a diode check now. So we're doing P1, doing diode. Diode only has to come up this high, like that. And the other diode, about the same. So this tube's passing fine. It's a good one. So that was the detector tube. We'll just keep working our way towards the front. The next one would be the IF amplifier tube. This guy's job is to make things strong. This is the amplifier in the radio. Well, most of the amplification takes place in this tube, as I understand it, in the IF, where the environment is extremely controlled, so they can enable the best output from this tube. Does that make any sense? He said no? Okay. A little quick line check here, just to be sure we're not way off. We're a little high. It's probably from me doing a rectifier tube and then not resetting it later. So a little high is no problem. And 12 SK7. There we go. 13 2. 10L. 10L. 17251. It's pretty dark in here for me to read this, by the way. 17251. That's to enable the video to pick up the writing up here. 4630. Once again, I'm suffering in my shop just to make a video. 0. What would actually suffer is the 2, because I got the numbers wrong. 17251. 12 SK7. 17251. 17251. 4630. 46330. 44. C. Okay, so this guy, 1520 is where it should come up about straight up, 13. Now, one of the reasons I'm putting this on video is I've heard from quite a few of you that you really enjoy watching tubes get tested, so here you go. Yeah. And the number is supposed to be straight up 15. Way over. So again, this tube is testing good like the rest. I think it's more indications that this is actually a low mileage radio. Somebody bought it and it looked nice on their shelf. Okay, the last tube is pulling out here. This is the 12SA7. It's a very, very busy tube. It's got a couple of grids. 12 SA7. Wrong way. The alphabet's running in the other direction here. 12 SA7 to bias 9L. 27345. 27345. 1650. 1650. I don't need to double check these because you're watching. 1650. 45. C. 1100 says whole tube. 13. Okay, any shorts in here? Okie dokie. And what is this guy supposed to come up to? 1100, just above the 1,000 there. That's where 1100. Wow, look at that! Holy smokers! Wow, this is a radio full of really hot tubes here, and that was it. That was it for that test. Excellent. Well, no surprise there at all, right? Because yeah, there's a surprise. No surprise. The radio's largely operating, but you know, I think gotta go from what you think it is to what you know it is. That's what we've done here. Now we've gone from thinking the tubes are good to knowing they're good. Great. Well, I think really all that remains here is an alignment, and I think I'm done at that point. Holy smokes, really? Yes, really. So I think it might be worthwhile to check a few voltages in here before going any further. And also, there's the resistor I took out. That's the cathode resistor, and I tested it outside. And what? Wait a minute. That's what I got. I got. You know what? Maybe there's something really wrong with this resistor because I don't know what that low reading was. 280 there. That's what it reads. 310. 310. So now it's 250. That's good. That's good. So if we're going to read voltages in here, we have to read them relative to something. I have the my lead from my voltmeter here. I have a choice. I can stick it on the chassis, or I can stick it on the B minus. The B minus is a much better choice. In fact, it is the choice that should be made. So a good solid B minus point is right here. See if I can clip on there nice and solidly. I don't want this to, come over when I'm not looking. Come and get into contact with the chassis or something like that. This isn't the best spot. You got to do something about this before we go any further. This is just run-of-the-mill masking tape, painter's tape. So just make sure this doesn't come into contact with the chassis. That'll do. That's good. Okay. So I've also made a little diagram here so I can't be fooled about which tube is which. So you got the 6SA7, 6SQ, 6SK, 6SQ, see how so easy it is, and the L6 and the rectifier tube here. Yes, definitely correct. Okay. And I also have the schematic up there so we can read some of the expected voltages. Voltmeters on, radio's not on. This will be the first time I've operated the radio since doing a little bit of work. Just watch the lights, and the switch is off to start. Good. Switch on. There we go. My voltmeter probe has a little switch on it, making AC voltages. And for reading DC voltages, this puts a resistor in series with the probe, and the meter's been calibrated to have this resistor during DC measurements. So if you accidentally leave this switched over to AC, radio warmed up. Beautiful. Okay, what are we going to start with? Let's look at the schematic here. I'm going to zoom this in a little bit more. You can see it a little easier. Why don't we start at the output tube? So 110 volts on pin number 3 on the output tube. Okay, pin number 3 on the output tube, and I'm going to be right in the way of the meter, aren't I? Okay, pin number 3. So 1, 2, 3. 110 volts. What am I on here? I'm on 50 volts. 150 volt scale. 110 volts should be up here. Okay, 1, 2, 3. So that's 120 volts, and it should be 110. That's fine. I don't think that's a problem. Now, there's this tube has two grid elements in it. So what's up with that? Pin number 4. Oh, the tube's upside down. Okay, so pin number 4 is a screen. So we should see a volt. They didn't write it on there, but we should see a similar voltage on pin 4. 1, 2, 3, 4. Ugh. Nothing. Come on. Oh, it showed up. I just had to knock on it a few times, I guess. That's a similar voltage, 90 volts. So the screen's a little lower than the plate. Sure seems like a good idea to me. So I think that checks out okay. We'll try the grid bias measurement here. Flip my meter onto negative, so a negative voltage goes upscale. Make it a lot more sensitive. 5 volts full scale. Now the grid on the L6 is pin number 5, next pin. So this would be the grid here. This might make some sound in the speaker. No? And what do we see on the meter? Hey, there's nothing much happening there. So tricky reading the voltage of a grid. So I shouldn't read the grid, I should read the cathode. The cathode is biased positive. Yes, Jim, that's what you should do. So we should see a positive bias voltage here, which really is a negative bias voltage right here. She went right over. Let's try again. So that's reading on the 15 volt scale, that's 7 volts. It's minus 7 volts. That sounds pretty good to me, but let's take a look at the book here and see what it says. Because it's not going to show it on the schematic anywhere. So there should be a number in here we can kind of compare. But it sure sounds fine to me. 35, what are we doing here? 35L6. Grid number 1. Grid. Typical operation, grid number 1, minus 7.5 volts. With fixed bias and 110 on the plate supply. That's exactly what's going on in here. Perfect. Perfect. Okay, on to the next two. Now from here everything should work out fine. If it works out on one tube, it generally works out on all of them, but not necessarily. So this 12 SQ7, we're looking for 45 volts. Almost full scale on the meter now. Pin number 6. Pin number 6. 2, 3, 4, 5, 6. Almost full scale. Just what we were expecting. Okay, that's perfect. We'll go back now to the 12. There's nothing else really to test on the 12 SQ and 12 SK. Plate voltage 78 volts. I can see it on the diagram there. SK plate is number 8. Plate is 8. Okay, oh, so 78 volts. So 150 volt scale, 78, just past the halfway mark. And this would be the one here. Just past the halfway mark. Good. Now this one also has a screen on pin 6. Should show pretty much the same voltage. Pin 6. So we go 1, 2, 3, 4, 5, 6. Pin 6. And we get about the same. Perfect. We'll try reading the grid here again, but I'm not sure what we can do with this meter. Grid would be on 4. Signal grid would be on 4. You know what they're doing here? They've got some tubes. Look at the way they've done this. No wonder the 12 SA7 tube image is upside down with the plate at the bottom. The SK7 is right side up, the plate at the top. What I would call right side up. SQ7, same thing, plate at the top. 35L6, the 35L6 is turned upside down. No wonder you get confused doing this stuff. No wonder I get confused doing this stuff. Okay, and what was I doing? I've confused myself. We're on grid of the 12 SK7 we're going to take a look at. Pin 4. Pin 4. 1, 2, 3, 4. This might make some noise. No. Maybe I have the volume turned right down. I get a weeny teeny voltage here of, that's a 5 volt scale, so that's like a 2.5 volts on it. And it's, oh my, it's positive. Okay, so wait a second. Wasn't one of these with a cathode resistor? 12 SK. Yeah, see? See, Jim? There's a cathode resistor. The 271 I replaced. So once again, we have to read the cathode voltage to figure out what's up. Okay, so cathode is on pin number 5. 5. 1, 2, 3, 4, 5. Out of the way. 5-volt scale, so we got like 2.5 volts of bias. Now, if we tune around, that might, I don't know, let's see what happens. Jump around. Oh. Why wouldn't this move? Oh, it's sitting on top of the... Okay, hold on. Hold on. Hold the fork here. Check out the radio. I can put the radio up on some blocks here because the pointer, it's sitting on the pointer. There. Now we're cooking. Okay, back to watching the grid. 1, 2, 3, 4. Was it 4? Double check, Jim. 1, 2, 3, 4. 4. 1, 2, 3, 4. Okay. 4. And why is there 0 voltage there now? Didn't I see a little bit there before? Going negative. Think, man. You're checking the grid, expecting a negative voltage. We switched from the grid to the cathode. Look, yeah, that's right. Okay, just catching up with myself here. So we can get that on either pin 3 or pin 5. Let's go pin 3. There we are. There we are. What do we got there? Now I'm going to tune the radio and see if this varies. That's what I was doing. Let's listen to it a little bit. Still won't tune. Is it sitting right on that? What's going on here? Oh no. Okay, so I have no idea why this radio won't tune like this. Geez, well, I have no idea what was just happening, but got stuck in the ditch there or something. Oh yeah, watch the meter. Oh yeah, meter. 1, 2, 3, 4. I think that affected the operation of the radio. Not 1, 2, 3, 4. That's the grid. We don't want to measure that. We want to measure the cathode. 1, 2, 3. 3. Okay, just catching up with myself again. 1, 2, 3. There we go. Vary the tuning and see if the meter changes. Oh yeah. There we go. So the lowest it goes, around 4. That's on the 5-volt scale, so that's not 4, that's around 1. It's around 1 volt. I think it's fine, but let's just look in the manual here and see what it says about a 12 SK7. It's going to tell me to look at another 2. Probably a 6 SK7. Look at a 6 SK7. JJKL 6 SK7. What is the typical grid number 1 control grid voltage? Positive bias value 0 max. Positive bias value. Not really sure what they're trying to say with that. I don't know what they're trying to say with that. Maybe it's in here again. Grid here, characteristics. Grid number 1 voltage -1, -3. -1, -3, those are the numbers in the book. We're right in that range here. Perfect. And the last tube to check would be the 12SA7. Plate voltage should be 78 volts. 12SA7 is this tube. And the number is pin 3, 78 volts. Pin 3, and 1, 2, 3. And that reading 90 volts. And there is also pin number 6, screen in the tube, pin number 6. 1, 2, 3, 4, 5, 6. Should get a similar sort of deal there. Come on, what? Whoop, whoop, come on. Reading a 0. Okay, what did I do wrong? Let's check again. So look at the schematic. 12SA7. Oh, yeah, I did do something wrong. You know, my eye slipped over to the other two. That's what happened. So 12SA7. It has 2 screens in it. They're on 4 at 78 volts. Okay, pin 4. 1, 2, 3, 4. We get 90 volts there. I think that all qualifies as pretty good, actually. I'm not sure there's anything else really to check here, voltage-wise. You can always take a peek at the top of these big capacitors here. I've got it all. It's not really worth doing. Not really worth doing. We've done enough. We have done enough. What is left now is alignment, tune-up, and that kind of stuff. That's what's left. So I think I'm going to leave it right here for today, and then tomorrow will be the finish up, do the alignment. Don't know what I'm going to do with that ugly cabinet. Not sure I'm going to do anything with it. So that's great. Great. Okay, so thanks a lot for watching, and tune in again tomorrow.